Hello viewers, welcome to my channel. So today we'll talk about DNS. So before getting jump into the DNS, let's first understand the problem and how the DNS is going to solve it. So suppose we have developed a YouTube video streaming application that is nothing but a YouTube dot in our own, and that we have deployed in the US, California, and it's having the host name as a youtube.com, and the IP address is 1.2.3.4. And we have a client here, basically that particular user, and it is having in his laptop, and in between the user and the server, in the backbone of internet, multiple switches and routers will be there, which will route the traffic from the client to the server and from the server to the client. Suppose the user want to watch the video in our video streaming site youtube.com, then it will enter the IP address of my server. So IP address of my server is nothing but a 1.2.3.4. These are my IP address. Whenever user enters the IP address 1.2.3.4, right, it will be routed to the nearest switch, and according to the IP it will route to the nearest router based on the IP, and this router will route the traffic to the nearest router, and accordingly they route the traffic with the help of switches and the router. At the end it will reaches to the server, and it will return back that particular video with the help of switch and the routers, and user will be happy, right? He requested to the video, he got the video, and he's able to watch the video. All wins, right? So what is the problem now? So the problem is when the user is not entering the IP address, right? Problem occurs when the user is typing www.youtube.com instead of IP address. Now this request come to the switch is not getting to know with the name where to route the traffic, like which router to route the traffic. Switches doesn't know, because these network devices, switches, routers, right, these works with the numbers, not with the names, right? So this is the actual problem, and with we humans are not with good with the numbers. This is the problem DNS is going to solve for us. And DNS is nothing but a internet phone book. We have used a phone book in our past before the mobile, like we had a phone book directory, right? Within that we have a name and with the corresponding number, landline number to that particular user. So whenever we wanted to call somebody, we check the that phone book directory with the name, and we got the number, and after getting the number we call that particular person and have a nice talk with them, right? Now let's check how the DNS store the information and how it works. So in the DNS, it is a kind of a collection of machines. So basically it is having a three levels of server. First one will have a root server, second level will have a top level domain server, and third level it is having authoritative name server. So basically in the authoritative name server will have the mapping of the host name with the IPs. If you see the first authoritative name server 2.3.4.5, here I have given the IP. So it is containing the information about the google.com, youtube.com, or related to the information about the .com will be present into this machine. Similar to this, in the another org related information will be present to this machine, and .net related information present into this machine, and .int related information present to this machine. And in the top level domain, it will contain the information about the authoritative server. So this top level domain will have the information about the authoritative name servers. We have a many top level domains like .com, .net, .org, .int, .gov, .uk. There are many are their top level domain, and it will point to the authoritative server. In the root server, it is having the list of top level domain to the IP address. Whenever somebody want to resolve the host name via IP address, the request will first come to the root name server itself. From the root name server, it will bifurcate to the lower level of the servers, and it will resolve the queries. So we have already seen DNS structure. In the top level, we have a root name server, will have the list of the top level domains, and the top level domain will have a authoritative servers IPs, and the authoritative server will have the mapping of the host name to the IP address. So now let's see one example. When the user is typing the www.google.com, then what happens actually? When the user types in the browser, so browser will first check in its cache, are they mapping is available to me or not. If it is not, then second level it will check with the OS. So OS will have their own cache, so it will check with the OS, it is having the mapping for this particular google.com or not. If OS is also replying no, it is not having, then it will check to the DNS resolver. The DNS resolver is nothing but it could be provided by our internet service provider itself, or it could be a third party like Google or Cloudflare. It will also caches the information about the mapping to the hostname to the IP. If it is having the information, it will return the information from the DNS resolver itself. If it is not having the mapping of the hostname to the IP address, then it will route the traffic to the nearest root name server. So now root name server will check this particular request www.google.com, and it will identify from the list the request will be for .com top level domain. So it will return the IP address in this request. Now DNS resolver will request to the top level domain.com with, so now .com server will check the request www.google.com, and it will return the corresponding authoritative name server IP address which is having the mapping of this request. Now the DNS resolver will query to the authoritative name server via the IP provided by the top level domain, and now that authoritative server receive the request from the DNS resolver. Now authoritative server will check this database, and it will return 5.6.7.8 this DNS resolver, and DNS resolver will cache this mapping, and it will return to back to the client that particular IP address, and client will happily receive that particular mapping, and it can request to the google.com by receiving the IP address. So this is how the flow will work, and each level whatever the requests are getting received, right, from each level like OS, browser, DNS resolver, root name server, top level domain, so all will going to cache this information. And if the same user or the any other user is requesting the same host name mapping with the IP address, that can be returned from the cache itself. And whenever some entry will be cached, like if this entry will be cached 5.6.7.8.com, there will be a TTL time to live. So when should expire this entry in the cache? So this is how the DNS will work. So there is not only one cluster will resolve the issue. Let's see how the DNS will resolve all over the world that particular query. There will be 1,000 of root server geographically located, okay, and which can be identified by these below servers. So there are these 13 servers which can be routed by any class. First cluster will have the first these IP, and second cluster will have also the same IP, right? And this third cluster will have one IP, and fourth cluster will also have a same IP, like that. So whenever the user request to that particular DNS query, that can be routed to the nearest root name server. So like that the query will be resolved, and there will be thousands of servers like this cluster are present into the internet which will resolve the query that are geographically located, and those are only pointed by these 13 IP addresses. And suppose somebody has deployed a new server, want to make a DNS entry into the authoritative name server, or he want to change the entry like mapping, he want to change a website or IP address. So user will update his entry into the authoritative name server. Suppose we have a new website like www.example.com, right? Will have a mapping to the IP 1.2.3.4. This new entry will be updated into the authoritative name server, and authoritative name server will update this to top level domain, and top level domain will notify to the root name server, and root name server will be going to sync these other root name servers to all over the globe, right? And this is how the traffic will be routed in the next time for any user which is trying to connect our server. This DNS propagation, right, whenever user make changes to the authoritative name server, this depend on the two things. One is the TTL plus sync scheduler, right, when it is scheduled. So whenever like it is scheduled for 30 minutes to be triggered, right, and if TTL is for 1 hour, then after 30 minutes it will be triggered, and once the TTL expired in the cache, it will updated in all the places. That's why in the real time, if you make any changes into the authoritative name server, it will say DNS record will be updated after 24 hour or 48 hour, 24 hour to the 48 hour, I think it will take it. So that's why it take more time to propagate the changes from one root servers to the many root servers all over the globe, right? So this is all about the DNS. I hope you like the video. Please do subscribe my channel to get to know more about the system design topic.